There you go. So let's look at this. Let's look at this. Now, some of you are going, why do you have to prove it? Just pick up something and throw it. Well, that's not proof. That's anecdote, right? That problem with showing me that it works in one case is the same reason that you can tell me my uncle smoked smoked 5 packs of cigarettes a day and lived to be 112. Right? That doesn't prove anything to me. That shows that your uncle was an outlier, potentially. So you have to prove something without a shadow of a doubt in order for me to believe it. So here you go. Here's a circle. That could be indicated by me spinning around with... Well, thank you. You're all weak. So, spinning around, here's my head, here's my arm, here is the path of the discus. My coach's claim, that's called a tangent line. That red line is called a tangent in geometry. Tangent is a line, we're doing 105 right now. It's a line that touches a circle in one point, or it touches a curve in one point and one point only. If it touches it in two, it's called a secant, which is also important, but not for this. Okay? My coach's claim was that that angle right there is a right angle. Now what I want to do is, we're walking through this geometric proof right now, is I want to tie it back to hypothesis testing and statistics. My coach's claim was that that angle right there is a right angle. That would be similar to the cyclist saying, I think that coffee lowers heart rate, or I think that fluoride lowers IQ, or I think that breakfast makes better students, or I think that heavy media multitaskers do worse on assessments than not. So the claim that that's a right angle right there, the claim, let's name these things, we have a reference, how about we call it ABC. Angle ABC is a right angle. That's similar to a claim, statistical claim, that you are then going to do a study to try to support. So you have a belief. You've got funding from the NSA or whoever, and you're going to go out and try to see if your claim has merit. You're going to try to see if your claim has merit. You set your control groups up, and you're going to set out to prove that that thing is a right angle. Okay. What do you do first? Think about what Harrison said about 20 minutes ago. What do you do first? What do you assume first about angle ABC? Oops. What do you assume about angle ABC at first?
That it's not a line.
You assume it's not. Good. And they said, okay, that doesn't make any sense. You assume it's not. You assume ABC is not a right angle.
I'm assuming you're not given the pretty drawing.
Well, you can draw the drawing, but you sure as hell can't put that yellow angle in there and call it a right angle without proving it to me. That's the coach's claim. Now, here's the deal. Why would we assume it's not a right angle? Remember what Harrison said earlier that was related to this? Well, assuming we've controlled for that. Remember what we said about why would anybody believe that fluoride lowers IQ? What's probably the original belief? That fluoride has no effect at all on IQ, right? Fluoride has no effect. If you're trying to prove to me that fluoride does have an effect on IQ, you've got to show to me somehow that the IQ moves away from the belief that it doesn't have an effect on IQ. So what we're going to do for starters is establish that null belief that, why would I believe that's a right angle? Maybe rule's just the freak, can't throw the damn discus correctly. Maybe. Let's assume that's not a right angle. Okay? Now here's where the proof comes in. Your statistical study. Here's your process. You decide to draw some other line. Because you tell yourself, because you remember geometry. Remember geometry, right? If you have a line and a point, somewhere you can draw a perpendicular. Anybody's ever built a wall knows this. You ever built a shed or put a floor in, anytime you square things up, if you've got a point outside of a line, you can get a 90-degree angle to that line. There, I call it right there. I'm calling that a 90-degree angle. If ABC isn't the right angle, then somewhere there has to be a right angle, yeah? Somewhere. I'm going to call it that one. Okay, is that okay? If he's like, okay, now you are saying, you confirmed. Prove to me why that can't be a right angle. Prove to me why that can't be. Harrison, go.
If you're going to let your discus go right there,
forget the distance. Just back to geometry. Strip it down to just the math.
A square triangle has 100.
Okay, so Deanne has just noticed that this triangle ABC is a right triangle, yes? It's a right triangle. I put a right angle in it. There's gotta be a right angle somewhere if I draw it in, might as well be there. Okay, held that thought. So triangle ABC is a right angle, a right triangle. Now, I'm gonna erase the rest of this. Actually, no, I'm not leaving it there. AC squared plus BC squared equals AB squared. Correct. I love that. There's something even simpler we can do. Hold that thought. Lauren? We could. It's something even simpler. In any triangle, where's the longest side? In this particular, in a right triangle, it's the hypotenuse.
You're the largest angle.
So clearly, the largest angle has to be opposite the longest side. So 90 degrees is the biggest angle in a triangle, in Euclid's world anyway. So AB has got to be the longest side of the triangle, yeah? So AB has to be longer than any other side of the triangle, including the first one that Deanne mentioned, which was AC, right? Because AC squared plus BC squared equals AB squared by Pythagoras. So clearly, and I say this with a wink, clearly AB is bigger than AC. And Sherry's looking at that going, I don't see how AB can be bigger than AC. Why, Sherry? Why? How can what is the problem with this statement?
Correct.
It's not true. Why is it not true? I'm going to add a point there, D, call it D. What's true about AB and AD? Aren't they the same because they're radii? So equal. So that means that AB has to be bigger than AD plus DC. But AB and AD are equal, yeah? Which means that DC is less than 0. That can't be the case, can it? Because it has length. So what do we call this right here? That's what we call a contradiction. You get down to a place, some of you at the point that I drew this in said, what the hell, that's the contradiction. It depends on what point you hit the contradiction. There is an irrefutable mathematical fact as to why everything before it is false. We got to a contradiction, yes? This is a false statement, that means this is a false statement, that means this is a false statement, that means this is a false statement. What was the first statement we made? The first assumption we made was that ABC isn't a right triangle. Therefore, what must be true about that statement? It must be wrong, correct? So in other words, ABC can't not be a right angle. And if it can't not be something, it must be that thing. You see what I'm getting at? Double negative right there? You just disproved that it can't be something, which means you've just proven that it has to be something. This is exactly the way statistical tests work. You go in assuming the opposite of what you want to prove, and you hope at some point along the way. No. This is numeric. This is numbers. This is the mathematics. You go in with a belief, the opposite of what you want to show, because the opposite of what you want to show is called the status quo. It's what you already observe in nature. For example, the injection of this vaccine in your arm will not cause polio, or will not cure polio, even though you spent all this work developing this polio vaccine. It's not going to work. It's not going to work. And then what happens in your clinical trials? You get far enough away from the belief that it doesn't work that you arguably say it has to work. That's the belief. You start by assuming the opposite. I want to show you why it makes sense to assume the opposite with actual data next time. But this procedure is exactly what we're going to do for the next 6 weeks together.
That's scientific inquiry.
That's exactly what it is. Every single scientific method is this. Every single one is this. Michael, what do you say? Go ahead.
So, because you said assume that angle ABC is not right,
yes, sir.
Prove that wrong, you can't necessarily say that, because if you said that angle CAB was not right, and then you did that, then you'd be saying that that angle was right as well, but it's not.
If angle CAB wasn't right. Angle CAB, you gotta watch angle CAB, because then you might lose the tangent at some point. If you pull that line too far back, you're going to lose the tangentness of line BC. The point is you have to have the line only touch the circle in one point. That's why the benefit of, you know it's going to be a right angle, your job is to verify without a shadow of a doubt that it is. If you try to pull angle CAB even close to 90, you're going to start losing that tangentness of BC.
Because it would go through.
Yeah, because you have to pull it this way, but then you're actually moving the angle as you go. Am I answering your question? I'm not. I don't think I am.
No.
I see what you're saying, D. Ask it again, Michael, in a different way maybe.
So, because we're trying to prove that angle ABC is right.
Yes,
That's ultimately what you're trying to.
that's the goal for this one.
Contradiction, right?
Right.
So what you did was you said, assume that that angle is not right.
So somewhere else, there has to be a right angle,
You
right?
have to prove the other side is
Well-
also not right.
It doesn't necessarily have to be a right triangle.
Oh, careful! I see what you're saying now, Michael. I'm going to fall back on one of Euclid's postulates here, and it's fairly. I mentioned it in passing earlier. Through a point,
Tangent.
not even tangent, simpler than that. Through a point and a line that the point is not on, there is exactly one line that you can draw perpendicular to that line. And if this isn't it, there has to be some other one somewhere else. So I'm falling back on you. I see what you're saying now. I'm falling back on the same postulate, if you will, that is why a chalk line works, kind of. I mean, this is actually a better explanation. If I need to build a wall off of that wall over there, so suppose I want to break this room into two smaller rooms, and I got to put a dividing wall up. From where I'm standing, I want it to be here to that wall. There is one point on that wall that makes a plumb line right angle to me. Euclid guaranteed me that. So the idea is, if this is not that line I need, then somewhere along this wall is the line I need. And I just drew it over here. I could have drawn it anywhere except to AB. I could have drawn it further out or nearer in, but all of them have the characteristic that upset Sherry, which is the fact that it went outside the circle. Anything except the tangent does that. Which means we get our contradiction at any point except for the tangent. Is that fair? Does that answer your question better? Better. Not perfect, but better. All right, good. Thank you, friends. More mathematics next time, I promise. I promise. Good with the biases today. I like that very much. Keep it coming. Just don't get frustrated when I say things like, don't worry about that. Worry about the math.
Did we finish the back rows of?
No, because poor Em got the weather. She couldn't get it to me yesterday, and I thought I was going to get it this morning, but I never saw Matt, who was so dropped off. I promise you a progress report this afternoon. Because if it's not on my desk today, I'm a little nervous. So we should have to Corvallis to go to classes. They should be sitting on my desk in a folder. You'll get a progress report from me ASAP. Okay? Good.
Typically, we should.
I'll be late on Monday, but I'll be here.